In October 2017, astronomers in Hawaii spotted an object from another star system hurtling into our solar system. A visitor from far, far away. A faint point of light moving rapidly across the sky. At first they thought it was an ordinary asteroid or comet, but its path and speed were unlike anything ever seen before. It was the first confirmed interstellar object ever detected passing through our solar system. They named it Oumuamua, which in Hawaiian roughly means the first messenger arriving from afar. We only had a few weeks to observe Oumuamua before it grew too faint and distant. Yet in that short time, this object managed to utterly baffle scientists and capture the public's imagination. What exactly was Oumuamua? And why did it become one of the biggest mysteries in astronomy in recent years? Oumuamua didn't behave like a typical asteroid or comet. For one, it was small and dim, only a few hundred meters in length at most. It had a reddish color, similar to objects from the outer solar system, suggesting an organic, rich, possibly icy surface. But when it passed close to the sun, it showed no coma, no fuzzy halo of gas and dust that a comet would usually display when warmed. Despite the lack of any visible outgassing, Oumuamua unexpectedly accelerated slightly as it moved away from the sun, a behavior usually seen in comets due to gas jets, but this time without the visible jets. Its motion was also peculiar. Instead of steadily spinning, Oumuamua was tumbling through space, as if it had been knocked around. By tracking its brightness, scientists inferred it's highly elongated or possibly very flat in shape, either like a long cigar or a wide pancake-type disk. In fact, the light curve, or the pattern of its brightness changes, it varied so much that Oumuamua might be 10 times longer than it is wide. We never saw the shape directly, it was just a dot in telescopes, but we do know that it's unlike anything normally found in the solar system. NASA described Oumuamua as a dark red, highly elongated object about 400 meters long, unlike any comet or asteroid observed before. All these odd traits, an interstellar origin, no cometary tail, a strange shape, and a tiny non-gravitational push posed a riddle.
In every way we expected these interstellar comets to behave, Oumuamua just acted exactly the opposite.
By mid-November 2017, astronomers were certain it wasn't from our solar system at all. Its hyperbolic trajectory and high speed ensured it would escape the sun's gravity and never return. So by all accounts, it appears we had an exotic visitor that broke all the rules, a true cosmic mystery on our hands. Naturally, scientists and the public began buzzing with theories to explain Oumuamua's weird behavior. With no clear answer at first, some wild ideas were put on the table. For example, perhaps Oumuamua was a chunk of solid hydrogen that formed in the extreme cold of interstellar space. A hydrogen iceberg could slowly evaporate and provide thrust without a visible coma, since hydrogen gas is invisible. This was a far-out idea, and later studies argued such a fragile hydrogen block probably couldn't survive the journey. Another proposal suggested that it was a piece of frozen nitrogen chopped off a Pluto-like planet around another star. Nitrogen ice could also sublimate without much visible trace, which might explain the object's high reflectivity and odd shape, as a chunk of nitrogen ice could erode into a thin silver. Other astronomers wondered if it was essentially a large, fluffy aggregate of dust grains, like a cosmic dust bunny loosely held together. A very low-density porous object might not produce a visible tail, and it could still be pushed slightly by venting gases or radiation pressure. Sounds kinda odd and funny, but it was seriously considered. And of course, save the best for last, the idea that captured headlines, what if Oumuamua was not natural at all, but some kind of alien spacecraft? One scientist, Harvard professor Avi Loeb, noted the object's unusual acceleration and suggested it might be an extraterrestrial light sail, a thin craft pushed by starlight. This alien probe hypothesis, while a minority view among scientists, got a lot of media attention. After all, Oumuamua's scenario felt reminiscent of Arthur C. Clarke's sci-fi novel, Rendezvous with Rama, where an alien ship masquerades as an asteroid. Before the name Oumuamua was chosen, some even nicknamed the object Rama, in homage to the story. Scientists took the alien idea with a grain of salt, but they didn't ignore it completely. Projects such as the Breakthrough Listen initiative listened for any signals from Oumuamua, just in case it was transmitting, essentially checking if ET had phoned home. The result? Silence. No radio signals or any technology signatures were detected from Oumuamua. It behaved like an inert object, not a powered craft. So as far as we can tell, it wasn't secretly an alien cruise ship. It's worth noting that by mid-2019, most researchers had come to conclude that Oumuamua was likely a natural object, not an alien artifact. But exactly what natural object? That was still hotly debated. Each exotic hypothesis, hydrogen iceberg, nitrogen iceberg, dust bunny, etc., had some sort of problem or needed very special conditions. The truth remained elusive until a couple of years later when a much simpler explanation began to take shape. Fast forward to 2023, and scientists think they've finally cracked the case of Oumuamua's weird behavior, and it doesn't involve alien technology or exotic icebergs at all. The answer, it turns out, might be plain old chemistry. In March 2023, a study by Jennifer Bergner and Daryl Seligman published in Nature proposed that Oumuamua is actually a fairly normal icy comet in disguise, just one that's been through a unique interstellar journey. Their key idea is hydrogen outgassing. Here's how it works. Oumuamua likely started as a water-rich, icy planetesimal, comet-like body in its original star system. During millions of years drifting between the stars, it was bombarded by cosmic rays. Those high-energy particles penetrated deep into its ice and caused a chemical reaction. Water ice was broken apart to produce molecular hydrogen, which got trapped within the ice. Essentially, Oumuamua's interior turned into a bottle of trapped hydrogen gas. When this object entered our solar system and neared the sun, it warmed up. Even though it was too small to spout a visible coma of water vapor, and indeed we saw no traditional tail, the gentle warmth was enough to release that of the trapped hydrogen gas from inside. Think of a sponge squeezing out gas. This slow, steady outgassing of molecular hydrogen would act like tiny thrusters all over the object, giving Oumuamua a little push, just the right amount of acceleration that we observed, without needing any visible jets of water or dust. Crucially, hydrogen gas is invisible to our telescopes and wouldn't carry dust particles out with it, so it wouldn't create a bright tail. This explains how Oumuamua accelerated like a comet, but looked like a bare rock. In the researchers' calculations, the amount of hydrogen released from a body of Oumuamua size could indeed account for the observed speed boost. The fact that Oumuamua was smaller than typical long-period comets made this effect noticeable. A larger comet wouldn't be as affected by such a thin shell of hydrogen ice, but a small 100-meter object could get a significant kick from it. One of the study's authors quipped that many of the earlier ideas were stupid or overly exotic, and that this hydrogen outgassing is the most generic explanation using standard physics and chemistry. In other words, we didn't need aliens or weird ice, just needed to consider a process that could happen to any comet roaming in interstellar space. The main takeaway is that Oumuamua is consistent with being a standard interstellar comet that just experienced heavy processing, said Dr. Bergner. You could start with a regular comet, and after cosmic ray cooking in a long journey, end up with something like Oumuamua, a comet that lost its volatiles on the surface and only released trapped hydrogen when nearing the sun. This explanation elegantly addresses all the mysteries: the small non-gravitational acceleration, hydrogen gas thrust, the lack of coma, since hydrogen is invisible and no dust was lifted, the odd shape, possibly a result of layers of ice eroded away during its journey or a collision long ago, and the tumbling, perhaps caused by outgassing torques or an ancient impact, all without invoking unknown physics. Turns out, Oumuamua may not be an alien invader or one-of-a-kind oddball, but rather the first example of a common type of interstellar object that we just hadn't seen before. Of course, not everyone immediately agreed. That's how science works. A few scientists, including Avi Loeb, pointed out that we still didn't see directly this hydrogen outgassing and argued that the calculations might need refinement. However, as of now, the hydrogen outgassing hypothesis is widely considered the leading explanation. It takes a once enigmatic phenomenon and grounds it in standard comet chemistry. In Seligman's words, it explains all the mysterious properties, and I can't think of a single theoretical barrier. So what is Oumuamua in the end? The best guess? An interstellar wanderer, likely a fragment of a comet-like body from another solar system, shaped by eons in space. It's a piece of cosmic flotsam that happened to drift into our solar system, giving us our first close-up encounter with material from another star. The mystery might be solved, but the story of Oumuamua has opened a new chapter in astronomy. For one, it taught us that small, dark, invisible comets, creatively nicknamed dark comets, might be lurking even in our solar system. Objects that outgas gently without obvious tails. In fact, inspired by Oumuamua, researchers identified several asteroids here at home that show unexplained, slight accelerations, possibly due to similar hidden outgassing. We might be finding out that the line between asteroids and comets isn't as clear as we thought, and there could be a continuum of icy but tailless objects out there. Moreover, Oumuamua was the harbinger of a whole new field, interstellar object astronomy. Amazingly, just 2 years after Oumuamua, astronomers found a second interstellar visitor, named Comet 2I, or Borisov, in 2019. Unlike Oumuamua, Borisov looked just like a normal comet, had a visible coma and a tail, and it behaved as expected. The contrast made Oumuamua's oddity stand out even more. Why was one interstellar object a conventional comet, while another was a comet in disguise? We don't have the full answer yet. The exciting part is that many more Oumuamuas are likely on the way. Up until recently, we didn't have telescopes sensitive enough to catch these fast, faint visitors. But new surveys like the Vera-C-Rubin Observatory Legacy Survey of Space and Time, set to begin in the mid-2020s, are expected to discover a lot more interstellar objects. Scientists estimate we might spot 1 to 3 interstellar objects every year once the LSST is up and running. Some of those will probably resemble Borisov, like regular comets, and there may even be some weirdos like Oumuamua. While Oumuamua may have been here and gone in the blink of an eye, it left a lasting impact on science. It forced us to think outside the box and revisit what we thought we knew. It sparked healthy debates, some wild ideas, and it pushed research forward. Most of all, it reminded us that the universe still holds wonderful surprises. A decade ago, interstellar object was theoretical, and now we've seen one up close. Who knows what the next one will look like? Maybe something we can't even imagine. As we await the next messenger from the stars, Oumuamua's legacy endures. The strange visitor taught us that reality can be just as awe-inspiring as science fiction. And sometimes, even the wildest science fiction might come true one day. Cosmos sent us Oumuamua as a wake-up call, a hint that out there in the dark, there are objects roaming the galaxy, carrying stories from light years away. It's up to us to pay attention and learn from these fleeting guests. So the next time you gaze up at the night sky, remember, something truly alien in origin passed through our solar system not long ago, and more are likely on the way. Oumuamua opened our eyes to a new frontier, one where each interstellar visitor is a piece of a puzzle far greater than ourselves, a puzzle spanning the galaxy.